Welcome back. In this video, I'm going to compute the limit as x tends to infinity for sine x over x, which will be a good application on sandwich rule. So first of all, if I try to replace x by infinity, I will get in the numerator sine plus infinity. But this term does not exist. So I don't know what sine infinity is, or what's happening, or what happened at infinity for the function sine x. And this due to the fact that this function is a periodic function that draw these waves till infinity. So for this reason, I need another method to find this limit. But I know that sine x, this function is bounded between -1 and 1. Because if you look at the diagram, if I draw the line y equal 1, this line will intersect with the maximum with sine x. Similarly, if I draw the line y equal -1, this will intersect with the minimum of sine x. For this reason, so I can say that sine x is between -1 and 1. But the thing is, I need this function. I need sine x over x. For this reason, I'm going to divide sine x by x, but I need to do the same thing on the other sides. And of course, here x, I can assume that it's positive because like x tends to plus infinity. Then after that, I'll go find the limit on the left side, or for the left-sided function, and the limit of the function on the right side, hoping that they will both give the same limit. Limit as x tends to plus infinity for -1 over x, this will go to -1 over plus infinity, this will tend to 0 minus or 0. Similarly, limit as x tends to plus infinity for 1 over x, this will go to 1 over infinity, this will go to 0. So here it's clear that the limit of the left-sided function, this went to infinity, to 0. Similarly, the limit of the right function on the right went to 0 as well, which means that the middle function, which is sine x over x, left with one option only, which is 0. This method is known as Sandwich rule or squeezing theorem. So as you see here, limit as x tends to infinity for sine x over x must be bounded between limit as x tends to plus infinity for 1 over x or -1 over x and limit as x tends to infinity for 1 over x. Since this one tends to 0 and this one tends to 0, and that's why we said that this function will be left with one option, which is 0.